All right, let's try this again. Let's say Fred, basketball player, has a free throw average of 65%. So that's already been determined. During a particular game, he has 7 opportunities to come to the free throw line. Okay, what is the probability that he will not make a single one of those shots? What's the probability that he'll make one? All the way up to what's the probability that he could actually make all 7 of those shots with a average of 65%. So, scoot down a little bit. All right, this is our binomial formula to calculate using the binomial variable. This is our binomial variable. This is x, and it is changing as we go. So this is a function actually for probability, again for binomial variable. All right, so this is probability of him making 0 shots. It is a combination of 7 trials, not making any of them, times the probability of success. So he's already stated at 65%. Did not make any of them. That means he failed 35%. He failed all 7 times. If you do a product of this combination times these 2 values in your calculator, you're going to get a 6.434 e to the negative 4 power. And what I wanted you to remember, that's why I wrote this up there, is this e to the negative 4 moves this decimal place 4 times to the left side. So once it moves 1, 2, 3, 4, you'll get a 0.00064339. Then I went through and calculated all the other probabilities. It's probability of making 1 out of those 7 free throws. It is still pretty low. You'll note that when you do the product, percent-wise, this is an eighth of a percent, so it is still very, very, very low, right? Probability of making 2, moving the decimal place over, would be 4%, still low. Probability of making 3 of those, well, that would be 14%, moving it over twice, if we're talking percents. Here's where his chances are highest. Either making 4 or 5 of those free throws, okay, from the free throw line. 7 times there, 4 opportunities, okay, and making all 4 of those. This would be the success. This would be the failure. He would be at 26% possibility of making 4 of those. Highest is going to be making all 5 of these at 29, almost 30%. Then it's going to fall off, which makes sense because he's only going to have a free throw average of 65. So the chances of him making 6 or 7 are a lot less. But if you total these up, they should be very, very, very close to our 1, our successes and failures adding up to 1. So, last but not least, you guys are going to be charged with making a histogram. Your variable, your binomial variable, and it's a binomial variable because it's measuring success and failures, from 0 to 7 for his chances at the free throw line. This is the probability. X-axis, y-axis. Y is nothing but your function of probability. And I have graphed each one of these. Now, this is a little off-center, and it's because it is the 65% is what's throwing it off-center, and so instead of being dead set in the middle of 7 at 3.5, it's skewed a little bit to the right-hand side with the highest possibility or probability of being at making 5 of those free throws, 5 out of the 7. So it's skewed just a little bit to the right. It's okay. It just does tell us, though, it would be slim chances that he would actually miss them all, or if he would only make 1. His highest chances are going to be making 5. Next highest chance would be making 4. We would think it might go backwards to 3, but actually he would have a better chance of making 6 before he would have a chance of just making 3. So I found this interesting. I hope you do too. I've got a couple of exercises for you guys to give this a try. Hope you have fun.